I am Professor Antonio S. Marajas, and this is Computer Applications in Industry. Let's now make a program using Siemens PLC on the examples that we have, which is the time delay on problem. Okay, so the first step is, again, if you notice in our previous example, you have a normally open contact, okay, and then you have an output. Okay, so the input here is represented by I 0.1 again, and then the output here, which is your CR017, will now be represented by Q 0.0. Okay, now since we have here one output, we go to the next network. Then in our circuit, again from our previous discussion, we have again a normally open contact, which is again your I 0.1, the input 1, and then we have here the timer. Okay, the timer, you click this rectangle or box here, and then you find time delay on, or TON. You select TON from the box. So here we have TON. Okay, this one. Okay, so that is your timer. Okay, so we have here question mark. Now from here you have a question mark here. Now if you will click the question mark here, then what will appear in your screen are timer numbers. So if you will see that you have T37 to T65, I believe, the multiplier for that particular timer is 100 milliseconds. So you put there T37, for example, then if you click it, automatically what will appear here in your screen is 100 millisecond. The TON here, by the way, is time delay on. Okay, so if you have 2, 3, or 4 timers, then you can select T37 and then T38, T39, T40 up to T63. The multiplier for that is 100 millisecond. So we have now to we are now required to put the preset time that we require for our time delay on. Now in our previous problem, the timer that we require is 8 seconds. Okay, but if you notice here that you have 100 millisecond representing T37, 100 millisecond as a multiplier. So what do you think will be our preset time here for us to be able to get 8 seconds? Okay, so your preset timer here should be 80. So why 80? Because you have 80 times 100 millisecond, that is equivalent to 8,000 millisecond, and once you convert that into second, it becomes 8 seconds. Now if you notice also that, again, I will repeat, our multiplier here is 100 millisecond. Okay, so our preset time should be 80. Why 80? Because 80 times 100 millisecond is 8,000 millisecond, and once it is converted to second, it is now 8 second equivalent. Okay, again, if you notice here that your output here cannot be found in your box, So you have to make the output again here in the network 3. So the output is separated from your timer. So you put here your output. So we place first a normally open contact. Okay, and then the output here. Okay, so the normally open contact here represents your timer T37. Okay, and then your output here can now be represented by Q0 0.1, no? That is your CR018 equivalent. Okay, so if we will discuss this particular time delay on, you have here if I0.1 is turned on, Q0.0 is energized. Okay, and then at the same time I0.1 here on network 2 will be closed. Then the timer will start the time. When it reaches 8 seconds, your T37 here will be closed, and then Q0.1 will be energized, representing your CR018. Okay, so that is how to program your PLC using the time delay on. Now again, if you have several number of timer, if you will use again a several number of timers, all you have to do is to represent your timer with T37, T38, T39 up to T65, which represents a 100 millisecond multiplier, and you have to find the number, in this particular case 80, for us to be able to multiply, for us to be able to obtain the 8 seconds requirement of your timer. Okay, so that is how to program your PLC on the time delay on program. Okay, now after this one, all you have to do is to click PLC and then compile for us to be able to determine if there will be errors in our program. So it shows here that there is 0 error. So that means that there is no problem with our program. Okay, so I hope that you understand on how to program your time delay on in your PLC.